Thank you for coming. It's my first time speaking at OWASP, and I'm really happy to be here. It's a great honor, and hope it's not going to be my last time. So today we're going to talk a little bit about web push notifications, and more to the point about how we can exploit them as attackers. So a bit of motivation, just if we try to think about what web push notifications are, or why will we at all be interested in them. So what if I told you about a theoretical mechanism that first allows you to have persistent access to your victim's browsers? Already sounds very interesting and nice for me to have as an attacker. Also, this mechanism is still under quite heavy development, so it's not something that has been built many years ago and it's ready and been tested many times. It's rather new, still under development. Not all browsers support it yet, and the features keep changing every day and are not that well documented. So it's not really standardized between the different browsers. Each browser reacts differently according to their own development. And finally, it wasn't really thoroughly researched from a security perspective, at least not that I could find. And usually, if you cannot find the research, it's either not so very good research or it's just not there yet. So just from these features about web push notifications, if you're a hacker, it might tinkle your fingers to start looking at it and start messing around with it. And just a few months ago, like really last May or April, something like this, Edge, Microsoft Edge, has started supporting web push notifications in theory. I say it in theory because even though they say we support web push notifications, I personally could not get it to work on Microsoft Edge. And this is really recent. This is just last May. Other browsers, such as Chrome or Firefox, have been supporting web push notifications for the last 2 years or so. Internet Explorer is not supporting web push notifications, nor will it ever, at least according to the information that I have. So you can see that it's not really standardized between the different browsers. So my research focused on Chrome and Firefox, as these are the browsers that are mostly used by the world. Okay. Microsoft Edge would have been in my research if I managed to get it to work, but I didn't, for reasons unknown to me. So generally, how did this all start? So a few months ago, I was having a discussion with my colleague here, Moti, sitting in the audience, getting angry yet again with yet another website asking for permissions to send me web push notifications. And me being a very anti-technological person, I always block it, always. But I was talking to Moti, and I was like, really, like users really accept this very evasive mechanism to send them push notifications to their browsers? And Moti, who is far more lenient to accepting new technology, was saying, yeah, sure, I use it all the time. It's great. I use it for WhatsApp Web or whatever. But for me, it was annoying. And more than the fact that it was annoying, it was becoming very, very popular. So I talked to him and said, have you ever looked at it? And he said, well, not really. So I decided to look into it. And very quickly, I got more and more convinced that it is not really the best idea to give random apps in the internet persistent access to your browser. And this is not hacking yet. This is just conceptually. Random apps in the internet, whatever it's a news site or a hacking site or whoever, can ask you for persistent access to your browser, and users just choose to grant this permission. So for me as an attacker, it sparkled a lot of interest, and I thought, okay, this is worth looking into. A bit on who am I. So I'm the tech lead at Comodo Consulting. Comodo Consulting, for those of you who haven't heard of it, it's a consulting company. And we focus mainly on web application security. So we try to help our clients and generally the world to be more secure when it comes to mainly web application, not only. I've been doing security stuff for quite some time now. We also write a lot about our security research in our blog, and all the stuff that I'm going to present here today, all the resources and code snippets and all of that can be found there, along with other cool research that we do. And really feel free, come to me after the talk or via email to talk to me about anything or everything security related or whiskey related or generally fun related. Happy to hear from you. So a bit of the agenda. We'll start with a big technical understanding, a bit of technical background and understanding on how this web push mechanism actually works, because this is something that I believe a lot of well, hackers, but also developers are not entirely familiar with, as it's a relatively new technology and, well, not that common after all. Then we're going to move to the fun bit of how we can actually crack and break some of these features that we'll present, starting with cool adware that we can build using web push notification or a denial of service to all the users, but adware is more fun. This is actually by exploiting a new vulnerability I found in Firefox that by now has been patched. We'll also see how we can build a cool botnet based on push notifications, how we can control our zombies to launch a DDoS attack against a victim. All of that whilst using Google or Mozilla as our CNC for our botnet, so we don't have to support our own command and control server. We can simply use one of those big names to launch the attack for us. Finally, we're going to see a new, rather new payload or attack vector for XXS, reflected XSS, to hijack notifications from other legitimate websites, which can allow us to elevate the reflected XSS to gain persistent access to our victims. We had a great talk about XSS earlier today, so to the list of payloads that was presented, this can be added as another new cool way for exploiting reflected XSS. So this is what we're going to talk about. And we'll start by understanding what are web push notifications, how really this thing is implemented. So generally speaking, web push notifications have three moving parts or three elements, components in its architecture. First, there is the client or victim, if you look at it from my perspective, which is the browser. A user running a browser, a supported browser. So as I said, Chrome or Firefox in this research, or Edge if you want to believe Microsoft. I don't, I try. So this is, obviously we need someone to send push notifications to. We will also need the server or the app or the villain, which is the actual app trying to send these notifications, the one that's sending us these annoying pop-up messages of please allow web push notifications, and finally, we're going to have a middle tier, a middle layer between the victim and the villain, between the browser and the server, which is going to be the service provider, either Google, Mozilla, or Microsoft. These are the providers that maintain the push API, the API used by the client in JavaScript to send push notifications from server to client. And they will receive, finally, the push notifications from us, from the app, parse it, do the verification on it, and distribute it to our clients if they choose to do so. And hear me? Yeah. Thank you. So this is a URL directed at the service provider, in this instance, Google. Okay? And as you can see at the end of the URL, there is a long random string which represents the specific browser of the specific user. Other than the endpoint URL, there is also a very important thing, the key, or the representation of the public key used by the specific app to send notifications to this specific endpoint. So in order for me, finally, the server to send notifications to this user, I will need to have the endpoint URL, which is provided for me by the browser, as well as the key, public key that I have as the app that will be used to send notifications to this endpoint. So this is created for me for every individual user when he's allowing web push notification. So as I said, now I can send him notifications, but there's still a question of what's happening when the user actually receives these notifications, or what is the behavior in the browser once those notifications arrive. So this is controlled by something called a service worker. Service worker is essentially the part that is responsible for manipulating the behavior generated after each notification is being received. And service workers generally exist outside of the scope or domain of push notification, but they're also used here. It's essentially a persistent JavaScript code that is stored on the user browser. Why do I call it persistent? Because you load it once you access the application, the server sends you a register order to register a service worker. This is registered to your browser, and then you don't need it anymore. The server does not need to present it anymore. It's contained in the browser. It will ever be there for accessing the specific application until it's manually removed, either by the app or the user. This service worker code, this JavaScript code, is responsible for consuming and parsing client-side events. Events such as notification arrived. This is an event that will be consumed by our service worker. Or notification was clicked, or notification was closed, or anything like this. These are events that can be consumed by our service worker. And what's important to note about this service worker is it executes JavaScript, but within a separate sandbox. So, for example, this JavaScript code is not allowed to access the DOM of the application unless in very specific and minor bits of the DOM. And it's not allowed to do many things that regular JavaScript from the website is allowed to do. This is, again, to protect the users, generally, from malicious JavaScript code. This is an example service worker. Can you see it at all, or is it really small? Really small. So let's try to make it bigger. Better now? A little bit more. Yes. It's within my powers. Yes. Hopefully you can see it now. It's not very complicated. By the way, I should say I'm a very poor JavaScript developer, so what I do, I steal. This is not really my code. Parts of it I tweaked, and these are the ugly parts of the code, okay? But the beautiful parts were not written by me. But generally what we do here, so we have a basic listener that listens for push events. We can see on the top of the code. This is what happens when you receive a push notification. You invoke a push event. And in this case, we write some stuff to the console, and we show a notification. You can see here, show notification. We pop up a notification to the user on the browser with, like this, with some content. We say, tada, 1, 2, 3, with some icon. We can also choose to vibrate, which will work on a mobile phone, but not on the browser, so it's pretty useless in this case. But as I said, I just copied this code. And finally, we also add here another consumer to consume the on-click event. So this is what happens when the user clicks a push notification. In this case, we are allowed to do a little bit of DOM interaction. As we said, it's a separate sandbox, but we are allowed here to launch a new window, a new tab on the browser, in this case, directing it to Comodo Security's website. So this is an example service provider, service worker. This was the client side, the victim side. Now let's look at the villain, the app side. It's much more simpler. refresh our keys. So I'll take this public key again. We'll put it into my apps code here. Reload the app. Enable push notifications again. I have here a new endpoint now, a new subscription object that if we copy and use here on our server, hopefully this time it will work. Let's see. Who knows? I didn't sacrifice enough Go to the demo gods, but and you see here this push notification. Okay? No. Whoa, nothing done yet. Nothing done. Okay, this is just a regular web push notification. You can see in the content here it says WhatsApp Web. Why does it say WhatsApp Web? Because if you remember in my service code that I showed you, I decided to show a notification that said WhatsApp Web with Tada 123. This is what I chose in my service worker, so I can do a bit of stupid phishing and send notifications saying WhatsApp Web, but that's not particularly interesting. So this is generally how web push notification look like before we start hacking them, okay? Client side, service provider, all looks fine. So time to get hacking. In the demo we've just seen, we consume the on-click event. I actually didn't show you this, but so let's show you this. So if I send another notification here, and I choose to click on the notification, again, why would it work? Okay, it doesn't work. If we look at the service code that I showed you before, we consume the on-click event. We say, okay, in case the user clicks on the notification, launch a new tab going to Comodo website. This is allowed by the API. And it makes sense. I send you a push notification, you choose to consume it, then you can launch a new tab. Fair enough. However, in my research, I found that this is actually not really the only case where we can launch these DOM events. Not the only case where we can launch a new tab on the user's browser. So let's tweak our service provider code a little bit, going back to this machine. So our original service worker looked like this. Okay, as we said, notification on click. It's exactly what I showed you before. Is it too small? Let's make it bigger. No mouse, so I'll do it. This. So hopefully you can see it. Yes, no? Too small? No, too small. Okay. Yeah, the touch thingy is not working for some reason. Yeah, it's not working either. I don't know. Yes, now? Okay, so this is the same code as before. We can see here, as I said, title was WhatsApp Web, and body was Tada123, all the same. And before we had this consumer here that we consume the notification click event. Okay, we add a listener for notification click event. So now we're going to tweak this service worker code a little bit. Here, I'm going to use a new service worker code that will also have the same notification on click event, but we'll also add this consumer for the notification close event. So this is the event that is being consumed once the user chooses to close a notification. Not click it, but close it. Okay, so now we can take, again, our app and direct it to the new service worker that we just created. Instead of service worker, it was service worker close. Sorry? Yeah, I know. Just one moment. Yeah, now it's saved. it is. Thank you. And let's now load our app. Load our app again. Hopefully now we have a new service worker registered, but who knows? Depends on the demo gods. If not, I will show you a video, but let's hope it works. Now I enable push notifications again, allow notification, all the same. I have a new endpoint, a new subscription created, and if I use this and just send a regular push notification, hopefully everything works just the same, and we can see a regular push message just like before. But what happens if I send another one? I just send another push notification, and as you can see, a new tab has just launched on the browser. What just happened here? I didn't close this previous message. What happens if I send another push? A new tab was opened, and another. A new tab was opened. So from this browser on the left, from the server side, I can just now launch arbitrary tabs as much as I want on my victim without the user doing anything, without user clicking a push notification, closing a push notification. What actually happens is that in Firefox, launching a new notification when the previous notification is still there actually invokes the notification on close event by itself. So by sending two subsequent push notifications, I can first send a notification, then close the first notification. And also, since Firefox sandbox is lacking, I can consume the on-close notification to launch a tab. So now I have a very cool adware that I can use to infect my users with adware. I can just send as many notifications as I want and open as many tabs as I want on the user's browser, eventually bringing it down. Yes? Yes, the victim has approved to receive notifications. So this is a malicious website, let's say Ynet, or I don't know, any other, that you allowed to send notification. And now I, as the malicious website, also use your permission that you gave me to plant adware in your browser. I can now have a persistent option to launch arbitrary tabs on your browser. Yes? Yes, you can send some JavaScript events. So it depends on your service worker that consumes what happens on notification click. So for example, I can, on the notification, send an encoded, instead of just regular URL, I can send an encoded base64 JavaScript code and then parse it from the service worker. However, it's pretty limited, okay, because there is a sandboxing for the service worker. So you cannot just, I don't know, start changing the DOM and adding features to the page or anything like this. This you cannot do, at least unless you find some way to break from the sandbox. But still, this is pretty cool, I think. So now you can crash users' browsers or just redirect them to my own ads and collect clicks on Google and make money from my adware. Cool. It even worked. So this is the service worker we just shown. I will not make it larger again, but again, we just consume the notification on close event and send subsequent push notifications to close the previous notifications. So as I said, I reported this this bug to Firefox, and a new CVE was born. So by now they have fixed this problem in version 59, I think. So what we just shown was on an unpatched browser. It might be the case in Edge. If any of you can get it to work, we can try it out. Cool thing to note about Firefox, so I reported this thing to them, and then we started some discussion with the developers, and it became very clear that they look at Google to set the tone, to dictate them how they should implement push notifications. So again, I guess it's a bit small. But the guy here is saying, oh, by the way, Chromium seems to only allow window interaction when the event is notification on click, so maybe we should do it too. And then they continue to say not the greatest things about their own code. This code is a bit hard to follow, but clearly this code could use some cleanup. So for me as a hacker, it says, if the developer cannot follow his own code, maybe there is something there. And it's generally open source. I did not dive into this code further myself in this occasion, but maybe if any of you has some spare time, this is maybe something to look into because, as they say, it's a bit of a spaghetti code that is not really well maintained. Other attack vectors. So we talked about adware. We've just seen how we can launch an adware attack. Cool. But are there more things that we can do? The short answer is yes. So we talked about it before. We can launch a notification-based botnet. And if you think about it for a moment, yeah, that's obvious. That's generally the definition of web push notifications, right? I have, as a user, control of numerous browsers that allowed me to run JavaScript on their browsers, okay, limited to some extent. But this is essentially a botnet, right? I have loads of zombies. I can run code on them. The cool thing is, however, is that we don't have a CNC. Okay, Google is our CNC. We just, as you've seen, me as the server, I just send my notification to the service provider, Google or Mozilla, and they distribute the notifications to all the other bots or zombies. Okay, my architecture will be like this. I just send notifications to a service provider, and then they distribute it to the victims that, in this case, attack my end victim. Okay, so these are my zombies. This is my victim. This is my CNC, and all I do is talk to Google, which is very straightforward, which makes this botnet a bit hard to take down, right? So if you are the victim here, if you've identified that you've been attacked by loads of browsers running web push notifications, what exactly are you going to do about it? You can ask each user politely to disallow these notifications, but unless Google decides to block the notifications by this public key, and of course I can have a multiple public key-based bot notification, it will be hard to take down, right? It will be hard for Google or Firefox to identify exactly which public key is used legitimately and which one is not, especially as the event finally is happening on the browser. The browsers are the one executing the JavaScript code. The service provider just launches notifications which are either legitimate or not. Okay, so conceptually, as a botnet, this is pretty strong. It's pretty hard to take down. So we need to adapt our service worker a little bit. Again, I will make it a bit bigger. So what we do here, again, we consume the push event, same as we did before when we showed push notifications to the user. We consume the push events, but here, instead of showing the notification show event that we've seen before, all we're doing is we're going to fetch our victim's site with a post request with a very, very long data, okay, which in reality will be very, very long. So now I can send, using this service worker code, I can send post requests to my victim by launching a web push notification, which is cool. But wait, I didn't consume the show notification. And you might wonder, wait. The whole point of web push notifications is to show web push notifications. And you're not showing a web push notification. Why is it even allowed? So the reality is not entirely allowed. It, again, depends on the different browser and different implementation of the push API, which varies between Chrome and Firefox and probably Edge as well. So let's see what happens in each of our browsers. On Chrome, if the user is currently connected, meaning the user is currently looking at our web app visually, it's open, the browser, and this is the current tab, there is no problem of sending silent push. It works just fine. So I can send as many network requests from your user browsers to my target as I want. If the user is not currently connected, and by the way, I didn't mention it before, but web push notifications are persistent even when the browser is shut down. Okay, so you shut down the browser, I send you push notifications. The next time you launch the browser, the attack is there. So if I do it in Chrome when the browser is closed or the user is simply not focused on this tab, it will be shown with this warning message. Have you ever seen it before? Well, if you're using web push notifications, you might have. It says this site has been updated in the background. So Google generally warns the user that something is happening, that is not entirely legitimate. It's not blocking the requests, though. So our post request will be sent from this victim's browser. So we can send silent push. In some case, it will not be silent so much from Chrome. From Firefox, however, our favorite, no issues. Yeah, no issues. So we can see here our very brief movie. Here on the right, I send push notifications to this browser focused on any tab, and you can see on the back there is a fiddler opening showing all the requests being sent. In this case, my victim is Walla, and you see requests are being sent without any issues. Okay, so I can send as many silent push as I want, or at least that's what I thought. I reported it to Firefox, and then they claim, aha, this is by design. This is intentional. We allow a small number of pushes that don't generate user visible activity. If the site does this too often, we will stop passing them the event, or at least so they claim. I have not launched the full-blown botnet and took a website down, but I did play with it a little bit, and I saw no throttling mechanism. I know there's a guy from Mozilla speaking in some other conference room today. I should talk to him about it. But OK, so now we can launch our DDoS. And we have generally two methods we can use. One is the caution mode, where we'll only use Firefox and Chrome users that are actively connected to our web app, and then it's completely silent. Or we can use our crazy mode, launch all zombies, and as many requests as we want, and we are risking our botnet being exposed. But then again, it's not that easy to take down. Finally, and we'll do it very briefly because I don't have any time, there is a question of how to infect our users with push notifications. So as we've mentioned, I can launch my own malicious website that just asks for the user permission to send push notifications and hope for the user to allow it. Press allow, and then I have my zombie. But we can do it in a more hacking way. Why ask for permissions? We can just grab them by exploiting reflected cross-site scripting. So in this instance, I'm assuming I found a website that uses web push notifications, and I've also detected a reflected cross-site scripting vulnerability in this website, Ynet, for example. Okay, I did not, but theoretically. So in this case, what can we do? If we look back at the permissions that the user has granted, we can remember that there were two parts. First, the user allowed a site, a domain, to send him push notification. This is when we send the allow button. And then there was the subscription element created containing the site's public key. Surprisingly, the two are not connected. And you can replace the public key without changing the permission model. Just go and replace it, very simply. How do we do it? So we use JavaScript, which is, again, what we can do if we have reflected cross-site scripting vulnerability. Two simple methods. One, unsubscribed. I ask my browser, stop receiving the notification from this public key. Do it very quickly. And then resubscribe using our own public key. So let's just see it happening very, very briefly. Oh, my goodness, my browser is collapsing. So now we're going to launch our browser, which is, as we know, connected to push notifications. I can send him push notifications from using this key. This is, on the left here, the legitimate app that sends push notifications. And now everything works fine. But now let's open here a new server. Okay? We have here a new server in the incognito mode. This is going to be the attacker malicious website. And as it's a malicious website, it has a different key from the legitimate one. So this is the public key that we are using, the legitimate one by the legitimate app. And here we can have the public key by the malicious attacker, which is a public key, a different public key than the one used to send notifications. And now let's assume here in my app that I have, let's open it. Let's assume in this app I have a vulnerability, a reflected cross-site scripting vulnerability. I will just launch my JavaScript code here through the console, but obviously you can launch it through cross-site scripting. So I'm taking this code here that I've prepared before. It's the same one that we've seen on the PowerPoint, just with the unsubscribed and resubscribed methods. That is also containing here our new malicious key somewhere. This key is our new malicious key. Let's copy our new malicious key, and we'll put it here. And now all I do as the attacker on the victim's machine, I launch this code. I launch the unsubscribe method and the resubscribe method. Now, by the way, already I did unsubscribe. Before I resubscribed, we can see that the original app can no longer, okay, I refreshed the keys. I was not supposed to, but generally they can no longer send this push notifications from the legitimate app. I unsubscribed their own public key. It cannot be used anymore. Now I will resubscribe the user, again, purely JavaScript, with my own key. Why is it not working? Let's try it again. Okay, it refused to work for some reason. I didn't put the key. Let's do it again. I have here the malicious key. Let's try it all again. These demo gods. Okay. First do unsubscribed, then resubscribe, and it's not working. So you'll have to believe me, because I don't have my demo working and I'm running out of time. But generally, this works, okay? We managed to get the original app to lose their ability to send notifications. And generally, if we tweak my code a little bit that was working yesterday, we can now send our malicious notifications and gain a persistent access to the user's browser. One last word, we did not change the service worker, so we cannot implement this to steal the service worker or implement our own service worker. We have to use the service worker of the original app. So if the original app was used to send notification and then open a tab, this is what we will do now with our own notifications. Unless we find another vulnerability we can exploit to put our own service worker on the app's domain. Reported this also to Google. Why don't you use a more secure mechanism like you do with SSL certificates and make sure the public key is actually owned by the people that use it? You can use some initial public key that will be signed by Google, and any subsequent key will have to will only be allowed once you prove ownership of the original key. And again, you can use for development process some self-signed key, but then you will have some warning message like you do in a regular SSL. Google declined this idea. Okay, it's pretty small, and I'm out of time. But generally, they said, yeah, but it's hard, and users don't like to use web push notifications anyway. And we worked hard, and no one uses our mechanism, so boo-hoo, generally. Okay, yes? The public key is used to verify that the person sending the push notification is holding a private key. Okay, but you can just replace this public key with simple JavaScript, and then the original owner of the original private key will not be able to send notifications anymore, and you will be able with simple JavaScript. Reflected cross-site scripting. Yeah, this is weird. I know. How come? I just told you, because they cry, that they are crying babies, that this is hard to implement. And I changed the public key on the app side. The private key I own as the attacker. No, because on the victim's browser, I put the public key that match my own private key as the attacker. It doesn't match the private key of the app, original app, so they cannot send it anymore. Okay? Make sense? No. Okay, we can discuss it. No, you don't need to change the domain. This is not a CA certificate. It's not a certificate. Maybe I wasn't clear. It's a new public key only for web push notifications. Okay, it's not the certificate of the domain of the site. Nothing like this. I didn't touch it. I just replaced the public key used specifically for web push notification. I offered Google to use something that is similar to SSL certificates. They cried. So it didn't happen. So to sum up, would you allow web push notifications? I started annoyed. I finished afraid. I will definitely choose the disallow button. If you Google web push notifications, most results are users begging Google or Mozilla to disable push notifications and get rid of this annoying feature. But developers like it, I guess, so it's still there. Questions? Yes? Marketing, yes. No users like it, except for Moti. Yes. The text of the buttons, I am not sure. Perhaps. I don't know. Ah, yes, let's have a selfie challenge. Don't pretend. Just have the best time of your life. Yeah. Yay. Thanks. Thank you.